The following is a presentation of Classen's Law of Technology Usefulness, presented by Cliff Soriano, Keith Weir, and Raphael Aries. Classen's Law. Classen's Law defines that how useful technology is to society is equal to the logarithm of the quality of the technology. Moreover, this suggests that as more technology comes about, it needs to be much more advanced than its predecessors to be moderately useful to people. We can express Classen's law mathematically using the logarithm function. Here y equals the natural log of x, or y equals the logarithm of x, where x is the advance in technology and y is how useful the technology is. Therefore, the usefulness of technology equals the natural log of the advance in technology. Since Classen describes the usefulness of technology to be related to the natural log of the advancement in that technology, then the same properties of logarithms apply. Therefore, a graphical representation of the natural log function is useful in providing a visual representation of Classen's law. Here the y-axis represents the usefulness of a technology, and the x-axis represents the quality of that technology. The curved exponential function represents a relationship whereby any positive marginal change in the quality of a technology brings about a correlated positive marginal change in the usefulness of the technology. It should also be pointed out that during the creation period of a new technology, that technology may not have any initial benefit or use as indicated by the negative value of y. As the quality of the new technology advances, it reaches a point to where it becomes beneficial and useful. You can see that when the quality of a technology increases, then the usefulness of that technology increases as well, but at an ever decreasing rate. Ultimately, the more advanced the quality of a technology becomes, the harder it becomes to achieve even a small incremental increase in the usefulness of that technology through any advances in quality. Using calculus. Since we're using the natural log x, then we can also apply the derivative to see how much the graph is changing. The derivative tells us how the function is changing or speeding up with advances in technology. So here the derivative of Classen's technology function is 1 over x. Next, we will talk about how this affects the overall future of the usefulness of technology. Looking into the future. Since the derivative of y equals 1 over x, then as x grows larger and larger, it affects the usefulness of the technology at a smaller and smaller rate. Therefore, as x grows larger towards infinity, the entire 1 over infinity becomes equal to 0. What does this mean for us? This suggests that as we continue down the path of more advancements in technology, x, ultimately having near infinite technologies, then the usefulness of all future technologies would be nothing, equal to 0. Of course, this would suggest that by the time we get to the point in the near future where technology no longer becomes useful for society, we will have more technology than we could possibly imagine. And any further technology would not be important to us. But does it work? Following this example, there is a slight problem. Before x equals 1, the natural log of x is negative. This would mean that early advancements in technology, such as the wheel, were actually harmful to the human race. Also, note that the natural log of e equals 0, meaning that technology has no use. But the negative value of usefulness may have an alternative interpretation. It may possibly mean that the wheel's design was initially so basic that it did not improve the current means of transporting people and goods. However, improvements in the wheel's design and composition soon made its use more and more beneficial. Since its inception, the wheel has positively impacted the transportation systems worldwide. Today, wheels are designed for faster travel and heavier loads. But now, technological improvements only translate into fractional improvements in performance. Here we shall apply Classen's law to the telephone. When Alexander Graham Bell invented the telephone, it gave people an instant way to communicate over long distances instead of by mail. This was substantially useful to people all over the world. When the cell phone was introduced around the 1990s, it provided the capability to make and receive calls from just about anywhere, improving its usefulness as a communication tool. Then cell phone companies added the technology of being able to send text messages. This added another format of communication to the telephone. Other capabilities were incrementally added to already existing phones, but were not amazingly useful to people until the iPhone. Since the iPhone and its sister iPhones have entered the telephone market, they have revolutionized how people and businesses function. The iPhone brought to the world an incredibly large amount of new and integrated technologies, and was very proficient at its ability to do everything its predecessors did, plus connecting to the internet, integrating an excellent camera, and thousands of apps. This amazing advance in technology actually did bring a great deal of usefulness to people everywhere, and so in this case, Classen's law is great. This graphic illustrates the previous telephone example. Notice how small improvements to the initial design of the telephone are plotted up to the point where x equals e. These small initial improvements in quality profoundly improved the usefulness of the telephone as the technology spread. Later, cell phones increased the usefulness of the telephone technology, but only slightly. The reason the iPhone caused such a comparative increase in usefulness is its profound increase in new and improved capabilities. Early innovations in other technologies provided a drastic improvement to their usefulness. Early internet dial-up allowed businesses to send and receive information, but was slow in the early stages. Broadband increases the speed of data and the capacity of information businesses can send, and greatly increases the productivity of businesses. The creation of Wi-Fi allowed companies and firms to connect their computers to the internet wirelessly, and also allowed several computers to use one Wi-Fi spot. Most recently, new cloud technologies have had a significant impact on business processes. The cloud provides the capability for companies to transfer, store, manipulate, and retrieve large amounts of data remotely from anywhere there is an internet connection. This service has proven especially useful to companies who cannot afford the cost of developing similar in-house capabilities. So, does Classen have a point? Will future technologies eventually become useless? Classen's law states that as the quality of a technology improves, so too does the usefulness of that technology, but it improves at a rapidly decreasing rate until further improvements have little or no use. While computers, phones, the internet, the cloud, and so on have provided such great progress and advancements to humanity, consider the new problems, such as pollution, cybercrime, identity theft, hacking, viruses, computer failure, full dependencies. While there are many more examples of the drawbacks of such technologies to companies worldwide and society, these could be factoring into Classen's law. This could be new insight into why new advances in technology don't offer as much usefulness over time, since part of the usefulness of the technology is lost to the new threats and problems it brings. Definitely something to think about.